What's poppin', dogs? Mr. Allen here talking Rafter layouts and all the math involved in this process. And we got a ton of it, man. We got proportions, Pythag, even some trig. And for this one, I'm going to be using our current Geocon build, which is a garage for our track and field crew. And this one even has some architectural plans, which we're going to use to get some of our real dimensions here, okay? So for this one, first thing we need is a roof pitch. So let's cruise on over to these wonderful plans, and I'm going to scroll down. I think it's the second page, or no, first page. There we go. I even circled it. We have a 412 pitch. Now what you notice is they show it with like a little triangle. The 4 is the rise, the 12 is my run. You can even get your hypotenuse if you'd like. That's a Rafter multiplier. More on that later. But let's go ahead and put our 412 into our little pitch area over here. Boom, I'll zoom in on it. We have 412, if you want to write it like a math, like a fraction thing. We don't reduce it in construction. It's always over 12 for our common rafters. And then for your hip or valley rafters, it's actually over 17. I'll do another video on that. Or you could write it as the, the construction way, rise of 4, run of 12. One of my students said today, they're like, I like it writing it like that because I can see that it's a rise and a run makes sense. I agree. I agree with that. All right. Another thing we're going to need is our building width. And really almost everything is based off of those two things. And then some of our dimensional lumber and thicknesses and things like that. So our building width, now there are obviously two dimensions of this building, length and width. But I'm going to go over to our architectural plans. And I actually looked at this part right here. Okay, because we ended up having to do some slightly different material thicknesses than what we originally had. We ended up getting 3/4 inch plywood instead of 1/2 inch, so some of those dimensions were a little different. But this one over here measures center to center of our framing material, okay? So we have 17 feet, 2.5 inches for the center to center, and I'm gonna show that, we'll zoom out a little bit more. That's to this spot right over here and right over here, okay? Now, we are using 2x6s, which are 5.5 inches wide. So if that's to the center of each wall, we're really taking off half of this 2x6 and half of this 2x6, or a full 2x6 is not accounted for in our total width. So what we're gonna do here is I'm gonna add all these things together. I'll write them down and then we'll put them into the calculator. I have 17 feet, 2.5 inches. And then we have our wall, the extra wall there, the 5.5 total, because it's half and half of it. So 5.5 inches. And then we'll also take into account our building, or our materials, our sheeting materials. But we'll do that in a moment, okay? So let's just do our framing material. We'll add those up. Now, in my calculator, what I like to do is I like to convert everything to inches here, okay? So 17 times 12 gives me the 204, and then I have plus 2.5 for the 2.5 inches, and then the next 5.5 inches, so 5.5. And I get 212 total inches there, so 212. That's my building width, okay? Now let's see if we can go back over here and what else we're gonna need, because we gotta take into account the sheeting, as I said, also our ridge, okay? We might not even know what that is right now, but that's okay. That's okay. We said, what was it again? 212, okay. So 212 inches for that part right there. Now my ridge and my sheeting thickness are gonna come into play here, and you see this run to math width, that's what I like to call it. That's the number we're actually gonna use to do our mathematical calculations, like some similarity with proportions, Pythag, things like that. That's one of our main goals right now, is to get that run to math width, okay? So our ridge, let's take a look at our architectural plans. Our ridge is made of LVLs, okay? So we have an 1.75 by 16 inch LVL ridge beam, but notice it says there are 3, and you can see the 3 X's right in there showing those 3 different boards sandwiched together. That's our ridge. So an 1.75 times 3 is what we have for our ridge thickness. So let's pop back over to our plan. So our ridge, we said, was an 1.75, 1.75 times 3. We could do this in our head, but when you're dealing with really expensive materials, right? In this garage, I think it's between 20 and 30 grand in materials. I don't want to leave things up to chance, so I plug it in the calculator. So we got 5.25 for our ridge. Okay, so 5.25 or 5.25. Boom, there we go. That's inches. It's kind of ugly. I'm going to fix that. 5.25. Cool. And then we have our sheeting thickness. So I said that one actually changed from the plans. It is 3/4. Okay, so 3/4 of an inch. Lovely. Now I got to figure out my run to math width. Okay, so we would take our building width. And there's actually two ways to do this. Okay, my building width, if we back out here, from outside to outside of the framing, so from this point here to this point here is 212 inches. Now you can see that we have this like triangle in the middle here. This guy right here, this is what I want to math with, okay? So it actually comes in from this red dashed line right here. So that's what I'm really looking to math with there, okay? Because that creates this nice right triangle within the structure, and then I can add and subtract things as needed, okay? So what is that number? Well, a couple ways, like I said, that you can go about doing this, okay? I can cut this thing in half, which would land me right here, okay? If I do that, 212, half of that is 106, right? So 106 inches to that spot. So from the edge right here to the center of my ridge, as you see it, okay? So I also need to subtract off half of my ridge. So I'd be taking off half of 5 1/4 from this. So minus, and this is going to look kind of ugh, but it's okay, 5.25 over 2. But don't forget, we have that 3/4 inch sheeting over here on the left-hand side. So I need to then add the 3/4. Oh my goodness, fractions, decimals. This is a mathematical mess right here. But we're figuring it out. We're going to be okay, all right? So I can take 106, I can subtract half my ridge and add in my sheeting. Let's do that right now, okay? So we pull the calculator back up. So 106, that was half of my 212, right? I'll just do it just in case. 212 divided by 2. Cut the building in half. Subtract off half of my ridge, divide by 2, and add the 3/4. And I get 104.125, okay? So let's keep that number in mind. I'm going to put that down here as my run to math with. 104 and 1/8, or 125, either way. I'll keep fractions over here on my answer line. And then, let's see here. I did say there was another way that you could go about doing this. Check it out, okay? So I could also take my building width, subtract off my ridge, add in my sheeting, and divide everything by 2. So I'm going to show you guys how that's done right now. So 212, I'm going to subtract out my ridge of 5.25. I'm going to add in both of my sheeting, right? So 0.75 times 2, or 1.5. Then divide all of this by 2, and I get the 104.125. Either way is fine, whatever you want to do. I always end up like splitting it in half first, and I take off half of my materials. But some people like to just do, okay, full width of the building, subtract the ridge, add your sheeting, divide by 2, boom. That is the run that we're going to math with. So we're mathing with 104.125. That's what we're going to use for our run right now. Now we can calculate some other awesome things, right? So not only am I going to be filling in all these answers right over here, I'm also looking for some of these dimensions over here on the right-hand side up next to our post, up to our ridge, okay? So all those are going to be key components here. Let me clean this up, get rid of some of this stuff here. All right, so we said our run to math with was 104 and 1/8. Over here, I'm going to work with some decimals, all right? So we got 104 and 1/8 inches. I just said decimals, 0.125. inches. Lovely. And I want to figure out my height. If you're having trouble figuring out what triangle I'm working with, let me outline it right now. I'm going to do so in orange so it really pops. I've got this run right here, which goes right to the edge of my wall, right next to my post that my ridge sits on. Okay, my post that I'm talking about is this guy right here. This is the post, all right? And my ridge is this part right up here. Okay, that's my ridge. So just in case you were a little hazy on the vocabulary, I got you. Next, the vertical guy. Let's get that at 90 degrees. Lovely. We're going to this spot right here. And then that light blue line that's dashed on through, that is our other one. I'm going to try and get it right below it so we can still see the dash because it corresponds to some other stuff as well. I think this is good. Beautiful. Okay. So that's my triangle. Okay. 104.125 is the bottom of that triangle. I want to figure out two things, all right? I want to figure out this length right here, and I want to find out this length right here. And just like a math class, I'm going to use X and Y for my variables, okay? We did say our slope of our roof is 412, right? Rise over run. Well, my run that I'm mathing with is 104.125. My rise right now is that bad boy right there, x. So let's set up a proportion off to the side here. I've got 4 over 12 equals x over 104.125. Rise over run equals rise over run. Let's cross multiply, solve, plug this into the calculator over here. Let me make sure that nothing's covering it. Beautiful. Okay, so 4 times 104.125 gives me 416.5. So 12x equals 416.5. Then divide by 12 on both sides. Sounds logical to me, man. Divide by 12, we get 34.708. Now, what are my units right now? Well, since I'm mathing with the 104.125, we are in inches, all right? So this right here, when I say 34.708, cool. 34.708 and change inches is my x value, okay? Now, how am I going to get my rafter length, my diagonal part right there? That's going to eventually lead to me figuring out my rafter length. So let's figure that out as well right now while we're in this whole triangle. I've got two sides of a right triangle. Sounds like I can hit this with some Pythag. Let's do that, okay? So I'll do that right up top. We've got in a different color, let's say this time. I'll go with more of a pink-red color. 104.125 squared plus, we've got 34.708 and change squared, whoop, equals y squared. Now, we do Pythag so much in this class, especially when you're solving for a hypotenuse, that I just plug it all in my calculator at once. So I'm going to do that. We've got the 104, second square root, because I know I'm going to square root. I almost always forget to type that in the calculator, and I have to do it after the fact. No big deal. So I got 104.125 squared plus, then I'm going to arrow up, grab that guy, square it. Look at that, it copies it right in. I could have done that with the 104.125, but it wasn't too bad to type. Hit enter, we get 109.757. Okay, so that is my rafter length from plumb cut to plumb cut. And when I say plumb cut to plumb cut, I'm talking about from right here where it's going to hit my ridge to right here where it's going to be at the edge of the wall over the sheeting, okay? So that answer that I just found right there is super duper important, and it is one of our answers on our answer lines. We've got rafter length, bird's mouth plumb cut to ridge. That's what we were just talking about. We said that was 109.757 and change. Well, am I going to find that on my tape measure? Not quite. So let's put this into tape measure terms, because this is inches right here, all right? So how do we convert this to tape measure? Well, tape measures are in 16ths of an inch. So if I were to subtract off my 109 right now, I'd isolate just the decimal. And if I multiply by 16, I can find out how many 16ths that decimal is, which I'd imagine is right about 3/4. 0.75 is 3/4. This one is, it's 12 16ths or 3/4. So on our tape measure, we'll have 109 and 3/4 of an inch, okay? So that's how you would convert it to tape measure reading. This one, pretty easy to see just offhand there, but some of the decimals get a little bit meh, all right? But awesome, awesome. We already have one of our main measurements right here, the rafter length, bird's mouth plumb cut to ridge. Okay, so what else do we have here? Now, some of these are going to be dictated by either the plans or what you choose to do or whatever. So this next one here, no math involved in figuring this one out. We are given this measurement, or we choose this measurement. Our seat cut, okay? Our seat cut is going to be 7 inches. Our walls are 5.5 inches. Our sheeting material is 3/4, so it's 6.25 inches. And I'm going to have that bird's mouth sit fully on that with a little bit extra, okay? So that was our logic there. So that seat cut, though, will dictate everything else here in our close-up of our bird's mouth, okay? So the bird's mouth is where it sits on the wall. We want this perfect right angle that's going to sit on top of our wall. We'll screw it in or nail it into the wall on the top, double top plate, and it'll all sit lovely and perfect, okay? So there are a few different measurements that we're going to figure out from this thing. It's our seat cut, which we already said is 7 inches, our plumb cut, and our hap. Now, this you could actually just lay out physically, okay, with your speed square or your framing square. Your 7-inch seat cut would hit the plumb cut. You could measure your plumb cut. You could measure your hap. You do not have to math these things up in the wild. We pretty much have everything else we need right now that we could just use our framing tools to do the rest. However, as a math teacher, and this being a math video, and this assignment being one of the assignments for Geocon students to math up a rafter layout, I'm going to continue mathing. And it's really cool to see if your math is correct when you actually measure it on the rafter. You're like, did I actually get all that right? It's a lot of work, okay? There's a lot, but we're going to keep on mathing here, okay? But everything here, we can lay it out in the wild, figure everything else out. Cool? So let's see here. My seat cut is 7 inches. Figure out my plumb cut from this. Check it out. So this little triangle right here, this little triangle, I'll highlight it again in orange. I'm just going to freehand this one. That right here is a similar triangle to our big orange triangle that we had right over here. Crazy, guys. Crazy. That's kind of a nice little thing. Let me get my calculator out of the way so we get full screen going here. There we go. So we have a lot of similar triangles here of the 412 variety. 412, meaning my rise is 4, my run is 12. Let's set up a little proportion action here. 412, okay, for this one. So 412 for this one, for all of them, equals, now, what's my 7? Is that my rise or my run? That is my run. So we'll have, I'll use x again because we're over here in this other spot, x over 7. So 4 times 7 is 28 equals 12x. Divide by 12. And we get x equals, now I need my calculator. Let's pop it back up. 28 divided by 12. We get 2.3 repeating. I'm going to convert this to 16ths as well. Subtract 2 times 16. This gives me 5/16. So we have 2.3 repeating inches, or 2 5/16 inches. Okay, let's put that over on our answer line. We have our C cut, we got our plumb cut. Plumb cut we said is 2 5/16. I'm doing basically all tape measure dimensions here because that's what we actually use this for, right? I did have my decimal down here, but then we converted it to tape measure. So I have my seat cut. I have my plumb cut of 2.3 repeating inches. That's a number that I'll math with if necessary. I'll use the fractions for when I'm actually doing it, but I'm mathing with all these decimals because it's going to be more accurate. How do I figure out my hap? Well, the hap is what's left over going diagonally through that dimensional lumber. Our rafters are 2x10s, okay, which are 9 1/4 inches roughly. It does vary a little bit because it's just regular lumber. Sometimes it shrinks and expands, whatever. So they're right around 9 1/4. What's left over for that hap? Well, I'm going to pop on over to the edge of this board right over here and extend some things out. So hopefully you guys can visualize this, okay? So if I were to extend this guy out here, and I'll use like we'll go with a light green, I guess. So this will extend out. This will extend out here. So my board that I have it's being cut out of a normal, 2x piece of material. All right, there we go. Let me erase some of this extra. So I'm making cuts out of this 2x10 piece of material. And we said this is 9 1/4, right? 9.25. I'm mathing, so I'm going to use decimals over here. Inches. Well, what if I were to draw that in right here? Looks like I have another lovely right triangle with 9 1/4 inches. Do you think that this triangle just might be, that is a really big orange marker now, just might be similar to those other triangles that we had in this entire diagram right here? Let's let it load. We got to back out. All my orange triangles are similar to each other, you guys. So I can use my 412 pitch once again to math this situation up. So let's do that. I'm going to grab a less thick marker here, but 412 equals, and then this one, my run, is the 9.25. So that'll go right down here, 9.25. And we'll call my rise, this guy right here, is going to be X. Okay. So what am I going to get? Let's cross multiply and solve. I'll pull out the calculator. 4 times 9.25. Divide that by 12. And we get 3.083. So x equals 3.083, repeating, inches. Is that what I wanted, though? It's actually not one of the pieces of information that I need. But it does get me to where I want to go, which is, or almost where I want to go, which is that diagonal length right there. That would be the plumb cut, and the hap added together is the full length of that board on that angle for this roof pitch, okay? So let's Pythag this thing now. We got 3.083 repeating squared. You usually don't put repeating in there for, fancy math, but street math right now, right? We're just figuring it out. 9.25 squared equals y squared. And let's plug this all into our wonderful calculator all at once. Don't forget that square root. I've gotten better at that. I'm going to arrow up, copy it in, square it, plus 9.25 squared. Hit enter, and we get 9.75 and change. So y equals 9.75 ... inches. I always put the ... if it's a value that keeps on going on, okay? So that's just how I like to notate things. A lot of other people do that too. So now, what we just figured out right there is all of this whole entire length right here. That's the 9.75 and change. So what are we going to do to just get the hap? If you're suggesting just subtract off the plumb cut from our bird's mouth, you are absolutely correct. So let's do just that. Let me get all that scribble out of there. Pull the calculator back up. I will have the 9.75 minus, I can arrow back up and get my 2.3 repeating somewhere up here. Boom, there it is. That is my hap, okay? So right off the bat, I'm going to subtract 7, multiply by 16 to get 16ths. But I'm going to write down the 7.417 equals 7.417 and change inches. And then over on our answer line here, my hap is 7 and 6.67 sixteenths. So 7 sixteenths. 7 and 7 sixteenths inches. Nice. Only a little bit more to go, guys. Only a little bit more to go. So, overhang and angles. Actually, to come back to that, okay? Let's work up here for a little bit. Let's see if we got anything that we need to figure out. Okay, now that we got that hap, there's a little more that's happening, if you will. All right. So we said my ridge is 16 inches. That was a given dimension, right? That was a given dimension. This is 16 inches. So my ridge here, we know is 16 inches. That's given to us on the plan. Whatever your material is, that's what I'll put there. If your ridge is a 2x6, then you're going to put 5.5 inches. If it's a 2x8, you'll put 7.5. Beyond that, it goes down to the quarter inches. But this one, 16 inches, okay? Now, our hap that we just figured out, the hap line, that is this line right over here, which is also, hold up, there we go, this right over here, okay? That is 7.417. What do we have there? 7.417. I'm going to leave that in decimal form. Okay? Now, why am I figuring this stuff out? Well, I need to figure out this post height right here, okay? Because I got to cut that post to pin the ridge, as it's called, right? Now, ours for this one actually runs continually through all the way down to the bottom plate. So we had to just do some other calculations. But normally, you would pin the ridge on the top of the wall. So I want to figure out what that length is. And it's a combination of a few things happening here. Well, this 34.708, which is what we mathed up for this triangle within the structure, plus this right here, gives me the entire height from up here all the way down to here. So if we add those together, and then we subtract off our ridge, that would leave us with just this area right here, which is the length that I want, so I can cut that part and pin my ridge, okay? So let's do all that dope math right there that I just talked about. We're going to add those two numbers together. Let me pull the calculator back up for me. I think you can see it sometimes and sometimes you can't. But I need to find my 7.417 417 plus, and really you could honestly use these rounded values. They're not terribly bad to use right now with rough framing, but why not yo-ro? Yo-ro. You only run once. Enter. That is my total height from the double top plate to the top of my ridge is 42.125, 42 and an eighth. Subtract off my ridge, and now I know that it's 26.125, 26.125 inches. That is my post height. This is a super duper important number to figure out when you are framing. Perhaps I should have had that as an answer blank, but we got it right here. This will be 26 and 1/8 inches. Let me write that as 26 and 1/8 inches. All right, will be my post height here so that I can properly pin the ridge. So we added in our mathed up Pythag answer from earlier, our HAP, the height above plate, to get our total height, and then subtracted off whatever our ridge was. Cool? Awesome. And I noticed that my answer line right here, actually we could fill these in now that we have them. We back out. This right here we said was the 34.708 inches. We just had them written off to the side. And then our total was 42.125. Oops. 42.125 inches. Lovely. Awesome. Fantastic. And these do go on forever, so I'll put a little ... action. But they are pretty solid numbers. All right. Cool. What else do we need here, guys? What else do we need? Well, all the nitty-gritty is taken care of, but we do have the overhang, and that's another thing that's usually dictated by whomever, okay? So our overhang here for this one is going to be a total of 12 inches. I'm going to do a little adding and subtracting off to the side here. So our overhang, a total of 12 inches. However, you have to take into account the fascia material. It's the part that goes on the front. Ours is 2x8. So 2x is 1.5 inches. So 1.5, that equals 10.5 inches, okay? That is the horizontal overhang, okay? We'll pop that over here. So 10.5 inches be the overhang horizontally. And then let's also find the overhang diagonally down the rafter. Check this out. So what we just said was that this dimension, let me pull my ruler real quick. This dimension right here, this is 10.5 inches. And I want to figure out what this guy is right here. And I'm using Y for a reason, because we've used it in the past. This is my X, that was my Y. Perhaps I bust out my orange marker once again. Whoop, whoop, whoop. That is a similar triangle. That's too obnoxiously large. Let me dial down the size of my orange marker. Boom, there we go. That is a 412 pitched triangle there. It's similar to all of my other orange triangles on this diagram, guys. So we can math it up in the same way. Check it out. So I can do 4 over 12 equals, my rise in this case is X, over 10, and 10.5 is my run. Let's plug it in the calculator. We'll do it all at once. We're doing a lot of the same calculations, so why the heck not? Plug it all in at once, divide by 12. Boom, 3.5 is my X value, so equals 3.5. What are we going to do next? Hit it with some Pythag. We got 3.5 squared plus 10.5 squared equals Y squared, all in 1 square root. Let's do it. Second square root, didn't forget it, 3.5 squared plus 10.5 squared equals 11.06. Is that 1/16 or no 16ths? Let's find out. Subtract 11 times 16. I've got 1/16. So 11 and 1/16. This is Y equals, what was it? 11.067 and change. 11.067 and change inches. Let's go down to our answer line. 11 and 1/16 inches for the Rafter edition, okay? And I have this guy in decimal. Let's make that 1/2, so everything's fractions over here. That's lovely. Now, Rafter length. I'm going to put this under here, Rafter length with overhang. We're going to add in that 11 and 1/16, okay? So, oops, with overhang. Hopefully we can see everything there. Let me double check. Looks beautiful. So I'm going to take this 11, this guy right here, plus my Rafter, which was the 109 and change. I'm going to use all these decimals here. It should be pretty darn close, even if we added the fractions, because it's only one rounding. But I do want to only round once. I don't want to round twice. We don't want to yort. So you get 120.825. That is wonderful. Okay, it's really close to 7/8, but not quite, because that's 875. So subtract 120 times 16. We have 13 16ths. So 120 and 13, not 3, 13 16ths inches is my Rafter length with the overhang. Nice. Nice. Now, let's finish this thing off. Angles. What are we going to use? Well, my rise and my run. So I got my triangle, my rise, 4, my run, 12. It's a right triangle, and I want to figure out what this angle is. That angle is going to be the same no matter how big this triangle gets, how we scale it. It's 412, all right? So what can figure out that angle? Well, if you don't know trig, it's okay. I got you. Across there, that is my opposite side. Right next to it, that is my adjacent side. Have you ever heard SOHCAHTOA? TOA is tangent. It's opposite over adjacent. So if I want to find the angle, though, got to use inverse, tangent inverse of my opposite, my rise, over my adjacent, which is my run. Plug that in, I will get my angle theta. Let's bust out that TI. Second tangent, 4/12. Fingers crossed this thing is in degree mode. It is not. That is a weird answer. If yours got the same thing, hit mode, arrow over to degree. Okay, so I hit mode, now it's red. I hit mode, I arrowed over to degree and hit enter. Now we can go back. That's more like it. 18.434. And then what's my other angle I'll need? Well, I want to make some right angles, so let's find the complement of that angle, 71.56. Now, what you're likely going to do in framing, we'll put 18.434, 18.434, ... degrees. In framing, we're probably going to, at best, go to the nearest half degree. So let's call it 18.5 degrees. And the other one would then be what, 71.5? Yeah, 71.5 degrees. I don't know why I want to keep decimals there for my degrees. I feel weird putting 18.5 degrees. I like decimals for that. I don't know why. I'm just feeling that way. But there we go, you guys. That is everything. That is a monster of a problem. I know it's a lot. I know it's a lot to follow. Rafters are difficult. They're difficult to calculate. It's hard to talk without a voice crack twice in this video now. But this is one thing there's usually one person, maybe a couple people, that actually know how to lay these out on a job, because there's a lot going into them. That's why they wrote books on these things, so you can just have tables and it does all the calculations for you, because there's a lot of math. Again, that second half there were things that we could probably just lay out. We could see it. No big deal. Don't have to calculate it. The main stuff you need is your Rafter length, bird's mouth plumb cut to ridge plumb cut right there. And other than that, once you get rolling with that and your pitch and all that stuff, your speed square, the framing tools do a lot of it for you. But if you lay this out, you'll see that all your math answers are incredibly close, if you did it right, to what you actually laid out, and that's pretty darn cool. So, hope you guys enjoyed it. Thanks for watching. Have a wonderful day, and keep on mathing and building.